Hi everyone, welcome to our Tariga Engineering Solutions, accompanies you in your civil engineering journey. So today we'll be discussing Introduction to Differential Equation. So basically, let's go back to our mathematics subject, engineering mathematics. Um, this will be the last part of the calculus, no, in our curriculum program. Well then, this course requires knowledge from differential calculus and integral calculus, which will be the prerequisite for this matter. Um, in that sense, I will be discussing another video for that, integral and differential calculus, in order for you to understand what is the content here in differential equation. So without any further ado, let's start discussing lecture number 1. Okay. Okay, at first, what do you feel about differential equation? Personally, when I was studying, no, like you, I feel very intimidated because the subject itself is very scary. No? Um, but lucky for us, our curriculum program does not go deep very well in the sense na it is very complex to understand. So most of the times, engineering curriculums um, they required us only to study ordinary differential equations. But for you, if you have the sense of learning in your heart, no, you you must or if you must go deep beyond this topic, well then it's good for you. No, it's good for you. Okay, so first of all, we need to define differential equations. What are differential equations? Okay, differential equations is an equation containing the derivative of one or more dependent variables with respect to one or more independent variables. So that is very self-explanatory. Um, as you can see, suppose let's go back to differential equation, differential calculus. When we get the derivative, that is suppose y is a function of x. So we must get a derivative of y with respect to x. Okay, so sort of that is a differential equation itself. No, so that's it. Okay, okay. So examples for differential equations. These are the examples that some of us very familiar with. Ito. So dy over dx is equal to 5x plus 3. So that is a sort of differential equation na. All of the differential calculus and integral calculus are all differential equation as one. No? So this differential equation is above integral and differential calculus. That's why from the beginning, I told you that the prerequisite for this subject matter is the differential and integral calculus. Okay, so another example is this one, no? E raised to y, second derivative times the second derivative plus 2 first derivative squared is equal to 1. Anyway, um, this form sort of when this is raised to 2, no, that is second derivative, and if that is 3, third derivative, and so on. So in this sense, dy over dx, that is only the first derivative. So anyway, I'll be discussing the order of differential equations later on. Okay, so another example, ito, this is another differential equation. Next would be this one. Yes, that is another differential equation also. Okay, and this is another differential equation. Okay, so those are the basic, no, or some of the examples that is above or under differential equations. Okay, types of differential equation. So the types of differential equations can be classified into two categories. Okay, so the first one is called the ordinary differential equations. So for engineering curriculum, we are bound to study this ordinary differential equation. But some of the schools offers, um, I don't know, they tackle also the second type of that, which is the partial differential equations. But within this video, we'll be discussing only the ordinary differential equations for you to be familiar with, and it can help you for your studies along the way for your journey. Okay, so what is a differential equation, ordinary differential equation? This is a type of differential equation that contains only ordinary derivatives of one or more dependent variables with respect to a single independent variable. Meaning, when you have an equation, a differential equation, where if you have a derivative of y with respect to x, all of the equations must be differentiated with only a single independent variable, which is the x. No? So pwede y in terms of x, or you may say t in terms of x, as long as it is with respect to one single independent variable. So that is ordinary differential equations, or we call that in shortcut, no, ODE. ODE. Okay. So the other one is the partial differential equation. Okay. So if the ordinary differential equation is bound to have a single independent variable only, ang partial differential equation is more, two or more, or any. Okay, so that's why it is called partial differential equation. Okay, it's a type of differential equation that contains partial derivatives of one or more dependent variables of two or more independent variables. So that's what I'm saying, no? Suppose y in terms of x, in one equation lang siya, no? In one equation, y in terms of x, the other is y in terms of t. So that is partial differentiation. Okay? So again, we'll be focusing only in here for the ordinary differential equation. Okay, let me give you examples for ordinary differential equations. Okay. So for example, like this, no? Yung equations that we had kanina, these are ordinary differential equation. dy over dx is equal to 5x plus 3. Why is it? It is ODE. Since yung dy or y is only a derivative of one single independent variable, which is x, no? Y in terms of x. That's why. Kana siya. So another is ito. So ang y differentiated with respect to x. So one variable only throughout the equation. So that's why it is ODE. Okay, and also this one. Okay, so as you can see, that's it. Right? Kana. And another, yan. Also this one and this one. So all of these are examples of ordinary differential equation. So for partial, di ba, we discussed partial differential equation. So we won't go deep here, but I will give you example. No, what does it look like? What does it look like? So yung partial differential equation is sort of ito. Kani siya. That is an example of a partial differential equation. So as you can see, there are two variables that are being differentiated, no? Y in terms of t and y in terms of x. So that's why it is called partial differentiation. Okay, so that's it. Oops. Okay, next one. Now we are done for the types of differential equations. We will now proceed for this one, no? Order and degree of differential equation. So how do you know the order and degree of differential equation? Well, sort of, most of the books, they only have they only have defined the order, no? Order. Kasi we heard about first order differential equation. second order differential equation or first order linear differential equation. Okay? So second order or nth order. So kahit ilan yung order. Okay? So how do you know its order and degree of a certain differential equation? Okay. So it is said that the order of a differential equation is determined by the highest order derivative. Okay? And the degree is determined by the highest power on a variable. Okay? So the higher the order of a differential equation, the more arbitrary constants need to be added to the solution. Okay. So, syempre, suppose yung order, meaning, suppose lang, there we have an equation of y double prime, no, or the second derivative plus something again. So the highest there is, suppose we could say the second derivative. So the order of that differential equation is 2 because of the second derivative. Okay? And the degree is relative to the highest order. Kumbaga, what is the highest power of the highest order derivative? Okay, if that is not clear, we will be having our example later on. So, the general form of nth order DE. So, generalize ko na lang siya, no? So, nth order DE is this one. So, d raised to n y, dxn is equal to a function of x, y1, y2 until yn minus 1. This function must be real numbers and it is continuous. No? Continuous. Because we need this when we get the general solution and particular solution. No? Kasi if not continuous, walang sense ang differential equation. Kumbaga ganito. No? Let me show you a MATCAD representation. So suppose, let's say na n is equal to 2. N here is the nth derivative of y with respect to x. So suppose when n is 0, so d raised to 0 over y, d raised to 0 over y, dx raised to 0, diba that is only equivalent to what? A number raised to 0 is always 0. So that would be equal to y. Diba? That is equal to y only. Kasi d 1 siya and dx is 1. So that is y only. So that's why if wala siya na differentiate, the function will be y if wala siya na differentiate. Another example is when n is equal to 1. Let's see. D raised to 1, y dx raised to 1. So if you could see that, pwede natin di ilagay yung 1. So therefore, that is dy over dx. So this is order 1. No? Order 1. And also, when n is equal to 2, d raised to 2, y dx raised to 2, just like kanina, okay? So kapag ganyan yung itsura, that is the second derivative. So that would be d squared y dx squared, or we will call that y double prime. No? And so on. If that is n is equal to 3, so that would be y triple prime. Okay? And so on until nth order, kahit ilan. Okay? So that's it. Okay, let's continue. Okay, examples. Okay, let's have an example. So, find the order and degree, if defined, of each of the following differential equations. So, ito. Okay? Number 1, dy over dx minus cosine x is equal to 0. So, if you will rearrange that one into implicit form, so that would be this one, no? dy over dx is equal to cosine x. Well then, dy over dx is equal to y prime is equal to cosine x. Well, ang dy over dx is just y prime. So kapag isa yung prime dito, meaning that is differentiated once. So that would be dy over dx. So as you can see, the highest, if you would observe this one, the highest order of this equation would be y prime. No? Meaning the highest order is the one, yung pinaka highest order derivative. Ilang beses siya gidifferentiate. Yun yung ibig sabihin yan. So that would be y prime. So therefore, the order is 1. Right? And let's look for y prime. The exponent is also 1. So therefore, the degree is equal to 1. Because as what we defined lately, the degree is the highest power of the highest order derivative. Okay? Kana siya. So number 2, xy times d squared y over dx squared plus x quantity dy over dx quantity squared minus y dy over dx is equal to 0. So if you will simplify that one into y prime, y double prime terms, so this will become y double prime because this is a second derivative. This is a first derivative, tapos is square lang siya. And this is y prime also. No? So that would be like this one. Okay? So I hope that is very clear. No? So the highest order or highest order derivative here is the y double prime because it is differentiated twice. So therefore, the order is equal to 2. Okay? And looking at the highest power, okay, that would be degree is always 1. Or not always, also 1 para, no? Also 1. So that is. So for the third examples, that would be 4d cubed y dx cubed plus sine x d squared y dx squared plus 5xy is equal to 0. So simplifying, kana siya. And syempre, if you will observe, yung y triple prime is the highest order. So the order is 3 and wala siyang exponent, so therefore the degree is still 1. Okay? So that's it. Okay. So let's proceed. We are done with the order and degree of a differential equation. So we'll now proceed with the linearity of differential equation. So when you say linearity of a differential equation, it is whether linear yung equation or non-linear ang differential equation. Do not misunderstood, no? There are nth order DE na linear pa rin. Okay? And meron ding nth order DE na non-linear. Meron siyang what do you call that? Basis, no? So dito. The ordinary differential equation is said to be linear if function f of x, y1, y prime until so on, y raised to n is equal to 0, is a linear function of variables y prime, y double prime, blah, 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 y raised to n. So, a similar definition applies to partial differentiation. So, sinali ko na lang dyan. Same lang yun siya. Basta linear function of variables. To be more specific, no? For general linear form of nth order DE. So, ganito lang. Ito. O, di ba, no? Ang sakit sa mata, no? Ang sakit sa mata. So, that would be the general form. Meaning, an sa an in terms of x, dn raised to y, or not raised to y, dny over dnx until parang binomial expansion, no? Kumbaga ganito, suppose let's delete this. N is equal to 2. So we will start at 2. So that would be a2 in terms of x. That would be d squared x, d squared y, dx squared. Okay? Plus an minus 1. So that would be a sub 1 raised to x. Until matapos na wala na siyang a sub 0 na siya. So that would be times, that would be dy over dx, right? Kasi 1 man lang. So hindi ko na lang sinali yung 1. So plus a sub 0 in terms of x times, okay? So, syempre, if 0, di ba, y na lang siya. No, y na lang. That's why. And that would be equal to g of x, a certain function. Kana. So, ganyan. Dapat linear ang order niya. No, na linear. So, from the highest order, if not arranged, at least if not arranged, at least they are in order like this one, no? Kana. But most of the times it is arranged gina siya. Okay? So that is a linear differential equation. So ito yung criteria. So para malaman natin whether it is linear equation or non-linear equation. For non-linear ODE, that would be simply one that is not linear, no? Self-explanatory. Kapag non-linear, so hindi siya linear. Okay? So it contains a non-linear function of one of the dependent variable or its derivatives such as trigonometric function sine y, exponential function e raised to y, and logarithmic function ln y. Okay? So that is a non-linear ODE. So examples for linear and non-linear ODE are this. Huh? Okay. Y minus x raised to dx, not raised, quantity y minus x dx plus 5x dy. So if we will, what do you call that? If we will simplify that one, that would be y dx, okay? Y dx minus x dx plus 5x dy, oops, equals to 0. So i-divide natin ng dx all over the equation. So that would become y minus x plus 5x dy over dx equals to 0. Yan, no? So ito, naging from here, i-rearrange natin 5x dy minus dx. That would be minus, plus na lang, y minus x is equal to 0. Pwede ganyan, no? So in that sense, that is a linear differential equation, no? From exponent 1 until wala na siya. Okay? Kana siya. So that is 1. Alright. So for non-linear ODE, so that would be quantity 1 minus y prime plus 5y equals to e raised to x. So that is a non-linear differential equation. Kana. So next would be ito, y double prime minus 5xy prime plus y equals 2x squared. Klaro, that is a linear differential equation. N equals 2, n equals 1, and n equals 0. Okay? So kana sila. And this one, kana. Cosine y. So di ba, if you, what do you call that? If you remember, kapag it will include cosine y, na differentiate yung y nasa loob. But if nasa labas lang yung y, tapos cosine x yan, linear na, no? Linear. Okay? Pero nasa loob man yung y, so it cannot be linear. So y triple prime plus xy prime minus 5y is also a linear ODE. And also this one is not linear. Okay? O non-linear na siya. Okay? Kala. So this is sort of polynomial, no? Polynomial. So, okay. Let's proceed. Solutions of differential equation. So there's a lot of solutions of differential equation, but we will be focusing most of it sa general solution and particular solution. But let's just define most of this. Okay, most of the solution. Okay, number 1 is called the explicit solution. Usually called simply a solution. No? It is a differential equation that satisfies the differential equation. So later on, we'll be having an example for that. For particular solution is a function that satisfies the differential equation but contains no arbitrary constant. So meaning it is particularly correct at a certain point of the graph of the solution. Ganyan mo na siya. General solution is a solution from which every particular solution may be obtained by an appropriate choice of values for arbitrary constant. Meaning general, it is having a solution with a range, no? All of that, yung nasa loob ng range are all particular solution. Okay? So the last one is called the homogeneous solution. Is the general solution to an ordinary linear homogeneous differential equation. If the equation is inhomogeneous, the homogeneous solution is the general solution obtained by setting the inhomogeneous term to 0. So that's it, no? But again, as what I've said, we'll be focusing on these two only. Kana. Kasi nandyan yung variable separable, exact differential equation, non-exact, first order linear differentiation, Bernoulli, kana siya. Marami. No? So we'll be discussing that for the next part of the video. Okay? So now, we'll be having examples na for this differential equation na topic. Okay. So verify that the given function or functions is a solution of the differential equation. So as you can see, this is a type of solution which is called the explicit solution. Dapat a differential equation must satisfy another differential equation. So let's see if this differential equation, let's say sa number 1, if this differential equation satisfies the first differential equation. Okay. So the differential equation must be y double prime minus y is equal to 0. Let's have this first. Ito, y1 with respect in terms of t is equal to e raised to t. So ito, let's say y na siya, no? Y. Ginawa ko lang y1 because merong y2. Dalawa kasi sila. Okay? So let's see. Y in terms of t is equal to e raised to t. So if you will to differentiate that one, what is the differential or what is the derivative of an exponent? Okay, so if you could remember, the derivative of exponent, no, is equal yan sa e raised to u times du. Di ba? Ganyan lang. So if you are familiar with that, if i-differentiate nyo to, automatic, e raised to t pa rin. Kasi if you were to differentiate t, that is, what do you call that? 1, no? 1 pa rin yan, no? Kasi wala man siyang coefficient. So, with respect to t man siya. Not x hat t ni siya. So again, if you are to differentiate that one, same lang pa rin, no? E raised to t pa rin. So we have now the first derivative and the second derivative here. So applying the differential equation above, let's see if it will satisfy. So the second derivative is e raised to t, that is here, inilagay natin. And y is yung wala siya, hindi pa siya na-differentiate, is e raised to t. So if you subtract them, syempre that is equal to 0. So therefore, we conclude that this y1 in terms of t is equal to e raised to t is a solution of this differential equation. So that is an explicit differential equation. Okay? That is how you get an explicit differential equation. Next would be the second one, the hyperbolic cosine. No? That would be, if you are to differentiate that one, a hyperbolic cosine, if you differentiate mo yan, that will become sine, hyperbolic sine. Okay, positive pa rin yan. I-check nyo yon sa calculus ninyo. No? Nandun yan sa calculus. So hindi ko na lang siya pinakita dito because we'll be focusing on differential equation man. We are not focusing on what you call that. Sa calculus, no? Kasi dadaanan naman ninyo yun. Okay? So, y, okay. So the second derivative, the derivative of hyperbolic sine is hyperbolic cosine. So bumalik pa rin. So by using this differential equation, let's see, no? So y double prime is ito. and y is cosine. So it satisfies also. So therefore, it is a solution of the given differential equation. Okay? Let's proceed to number 2. So that would be ty prime minus y is equal to t squared. So dapat ito, yung y equals 3t plus t squared, masatisfy na siya. If not, meaning this 3t plus t squared is not a solution with this differential equation. So let's check. Y equals 3t plus t squared. So if you differentiate that one, so that will become 3 plus 2t. Diba? Y prime is 3 plus 2t. Differentiating more, that would be y double prime is equal to 2t. So by using this relationship again, t times y prime, so t times this, ito yan. T, yung 3 plus 2t is the y prime, minus itong y. Y is ito, 3t plus t squared. So if you are to consider, if you are to simplify that one, distribute yung t, it will be 3t plus 2t squared minus 3t minus t squared. So ito yun. Kana siya. Okay? So as you can see, cancel si 3t. Diba? Because they have same variables and opposite sign. So 2t squared minus t squared, syempre, that would be t squared. So therefore, it concludes that yung t squared na satisfy yung equation dito. Okay? So well then, if satisfied, therefore, 3t plus y, 3t plus t squared is a solution of ty prime minus y is equal to t squared. Okay? Kaya siya. So next. Okay. Okay. So next is obtain the differential equation of the family of straight lines with slope and y-intercept equal. So this is not yet general solution, but rather we need to get the differential equation out of an equation. So practice lang muna sa pag-create ng differential equation. So syempre, we cannot directly go to general solution and particular solution, no? Kasi mayroong mga methods doon. Okay, so first we need to practice lang sa dito. So obtain the differential equation of the family of straight lines with slope and y-intercept equal. Remember sa analytic geometry, you have a slope-intercept form with the equation must be y equals mx plus b. Okay, I know you're familiar with that. Slope-intercept form. Kasi bakit slope-intercept form yung ginamit mo, sir? Well then, the problem states with slope and y-intercept equal. So therefore, you need an equation that contains the slope and y-intercept respectively. So there is no standard form of a line that corresponds with slope and y-intercept aside from this. Ito lang siya. Okay? So dapat daw ang slope and y-intercept are equal. Saan ba yung slope and y-intercept? Yung m is the slope and yung b is the y-intercept. So for them to be equal, so m is equal to b, let's say that letter C na lang yung i-denote natin. Letter C stands for a constant value. Okay? So letter C or C stands for a constant value. So if equal si m plus b, i-substitute natin as C, that will become y is equal to, instead of m, let's say C na lang yan because of this. Okay? And yung b is C na rin yan. Okay? So we will start from that. Nagiging ganito na siya. Na-factor out natin yung C because it is common with this term. And if you will rearrange that one, para hindi tayo mahirapan mag-differentiate, let's say C is equal to y over x plus 1. Okay? So y over x plus 1. So after this, you isolated now the equation. In order to get the differential equation, we need to differentiate. Okay, so how to differentiate this one? So remember sa calculus, you have derivative of u over v. This is u over v because y and x are variables. So dito. Remember that derivative of u over v is equal to v du minus u dv all over v squared. So let's do this form, no? Para i-calculate dito. Okay. Siyempre, first, anyway, this is so-called implicit differentiation, no? We will differentiate both sides of the equation simultaneously. So dito, differential, c is a constant. So a derivative of a constant is always 0. Okay? So that's it. Okay. So 0. Okay, let's review this one. Okay. Yung x plus 1, okay, let's put this, no? Ito yung u, ito yung v. Okay. So from that, ang v is, unahin natin yung denominator, x plus 1 raised to 2. Squared. So v squared man siya. So v du, so v, ang du, so derivative of y, syempre if you will differentiate y, that will become dy over dx. Okay? Minus y, u dv, y, u. Okay? And differential or derivative of v is x plus 1, so that would be 1. Right? 1. So again, we will differentiate lahat with respect to x. Okay? Because this is ODE. Okay? So that is, if you're to simplify, if we cross multiply mo to siya, 0 times any number or any variable must be 0. So that would become like this. Simplifying, okay, that will become y dx minus quantity x plus 1 dy is equal to 0. So ito na yon ang differential equation of the family of straight lines with slope and y-intercept equal. Okay, so that is correct in any family of straight lines. Dapat equal ang slope and y-intercept. Okay, so let's have another example. Obtain the differential equation of all straight lines with algebraic sum of the intercepts fixed as k. Okay, so how do you solve this one? Dapat intercepts fixed as k, algebraic sum, meaning the sum of intercept is equal to k. So let's say ito, from intercept form, so sa equation of a line pa rin, that is x over a plus y over b is equal to 1. So, di ba ito yun, no? Intercept form. Where a and b denotes the x and y intercept respectively. So a and b are intercept. So a and b are constant, no? Constant na siya. So the problem states that the algebraic sum of the intercept must be k. So let's say k is equal to a plus b. Okay? Now we will use this relationship in order to have a is equal to k minus b. Dapat kasi sa differential equation natin, merong lalabas na k because dapat fixed as k. So therefore, merong k dapat. Okay? And rather than wala tayong makita na constant because sa differential equation, meaning yung mga arbitrary constant, as much as possible, ma-eliminate na siya. Okay? So a and b are constants here. So a is equal to k minus b. So ano pa ba? Ito na. So substituting a here, ak minus b, so it will be like this. Okay, so k minus b and b are constant again. Constant pa rin na siya, no? Constant. So if you were to differentiate that one, i-factor out mo lang yung 1 over k minus b. Okay? So pwede kasing ma-rewrite yan into like this. 1 over k minus b x plus 1 over b times y equals to 1. Pwede ganyan, no? Pwede nating ma-rewrite yan. So therefore, if you are to differentiate all of that, lahat, so it will remain lang ni siya, and ito magiging 1. The derivative of x is 1, and it will remain kasi constant, and derivative of y is dy over dx. So derivative of constant is 0. So ito. Okay? So yan yung nangyari. Sinabi ko kanina, no? 1 over k minus b, derivative of x is 1, and 1 over b, derivative of y is dy over dx. Okay? Now, we need to have b in terms of k para again, it will eliminate the function b here or the value b and lahat na lang magiging k. Okay? So, if you were to transpose that one, magiging ganito. 1 over b times dy over dx is equal to negative quantity 1 minus k minus b. Okay? Or, you may say, same pa rin, ito, equals, instead na merong negative, baliktarin lang natin to 1 over b minus k. Di ba? Pwede yan, no? Pwede ganyan. So, after, so now, let's say, dy over dx equals to y prime na siya. Di ba, no? Equals to y prime. So, instead of dy over dx, let's say y prime na lang na siya. And that will give you y prime is equal to b over b minus k. Right? Ito. Naging ganito na siya. So, ito na yung makikita ninyo. Hala. So, i-simplify natin. Na. And again, okay. So, that would be ito. By prime. I-distribute natin yung y prime. So, that will become ito. B equals ky prime, y prime minus 1. So, simplify ko na lang ito. Simplify. So, kayo na lang yan. Algebra, no? Basic algebra. But anyway, pwede man natin ma-transpose yan. So, from here, naging ganito. I-distribute ko lang yung b minus k, i-cross multiply. Since dy over dx is y prime, is equal to b. Distribute y prime, naging ganito. And i-transpose ko yung by prime doon sa kabila. And that will become ito. No? Okay. So, that's it. Now, substitute this to equation 1. So, ang b is equal to ky prime over y prime minus 1. So, ito na. Substitute natin. Okay. So, instead of b, ito na yung gi-substitute natin. Tignan ninyo, no? Ito, b man siya. Kini. B man. Right? So, that is b. Okay? Kaya. Simplifying, ito, unahin mo natin to. Para equal yung denominator dito. Okay? So, that would become this one. Okay, algebra, no? Algebra. So, ano ba yan? Ito na yung simplification. Okay, since they are common, y prime minus 1, y prime minus 1, pwede natin yan ipataas. Okay? Pwede natin ipataas yan. So, it will become like this. Okay. And bakit naging negative k na lang yan? Because ito and ito, cancel na siya. Because they have opposite sign. No? Kana. Okay? That's it. So that would be this one. Okay. Simplifying, i-simplify pa natin further, it will become this one. Ky. So instead, di ba, ito yung mas malaki na least common denominator ba, LCD. Ito. So this divided by this is negative y prime, so that meron siyang negative y prime dito na multiply dito, no? So ito. So simplifying that one, i-cross multiply mo lang yung ky prime doon, it will become like this. Y prime minus 1, y minus xy prime is equal to ky prime. This is now the final answer. Okay? Final answer na siya. So this is now the differential equation of all straight lines with algebraic sum of the intercepts fixed as k. Okay? Next. Obtain the differential equation of all parabolas with axis parallel to the x-axis. Okay. So, di ba, ang x-axis is ito, horizontal. And vertical is yung y-axis. So kapag ang parabola goes opens left or right, the standard form to that is ito. No? Y minus k quantity squared because again, ang itsura ng opening yan is whether pag ganito or pag ganyan. Magiging opens to the right siya if positive 4A. And to the left if negative 4A. Okay, so anyway, that is analytic geometry, no? So clearly, ito yung equation na gagamitin natin kasi yung axis of symmetry is parallel to the x-axis. Okay? So now, we have three constant, no? Tatlo yung constant. It is k squared, 4a, k, 4a, and h. So there are three constant, meaning there are three arbitrary constant. We need to differentiate that one 3 times. Because if you remember, the higher the order, the more, di ba, that will have a relative number of arbitrary constant. Meaning, if 3 yung highest order, 3, third order, there are 3 arbitrary constant. So let's say, alam na natin na yung sagot dito dapat in the third degree. Not third order differential equation. Because tatlo yung arbitrary constant. Okay? So let's say, constant man na siya. Let's start with 4a kasi dito nasa labas man siya ng parentheses. Mas madali siyang i-differentiate. So that would become like this. Okay? So 4ac and ito. C is equal to quantity y minus k raised to squared, no? X minus h. Differentiating, okay, implicit pa rin. So ito yung i-differentiate na siya. Medyo mahaba na siya, no? U dv pa rin siya, u over v. Okay? So ang v is x minus h and ito yung u. So v ang du, ito yung du. So chain rule, 2 times y minus k and the derivative of nasa loob, constant man ng k, so 0 lang na siya, and derivative of y is dy over dx. Minus quantity y minus k squared and derivative of x minus h is 1 minus 0 or only 1. Okay? So simplifying this one, if i-cross multiply mo siya, magiging ganito. Okay? Kana. And if you are familiar, ang y minus k and y minus k isa makancel. So magiging ano na lang, 2x minus h. Okay, gi-replace ko siya ha. Ang dy over dx, gi-replace ko siya ng y prime. And gi-transpose ko na lang sa kabila yung y minus k na natira. Okay? And if you are to simplify that one, i-isolate natin whether h or k. Kasi mag-differentiate man tayo once again. So, one time pa man tayo nag-differentiate. So, from that, let's say ito. H, gi-simplify ko na yan. No? Gi-simplify ko na yan. H is equal to x minus y minus k over 2y prime. Differentiate. Okay. So, differential of h is 0. Differential of x is 1. So, magiging u over v pa rin. U over v. Right? So, this will become, ang v is 2y prime and yung u is y minus k. So, that would become, ito. V is 2y prime, u is y minus k. So, syempre, if i-derivative natin yan, y minus k, y prime na siya. Minus y minus k, ang 2y prime, if i-differentiate, maging 2 double prime. Okay? Does it make sense, no? Kana. Algebra na tayo. That would become, ito. Transpose lang sa kabila para maging 1 equals 2y prime, y prime, and y minus k 2y prime over 2y prime squared. So it will become ito. Okay? I-cross multiply. And naging 2y prime squared na siya kasi dalawang y prime. Okay? Dalawang y prime. So squared. So simplifying, we need to isolate k naman dito para last na ni siya nga pag-differentiate. Okay? So k is equal to y plus y prime squared over y prime. Kayo na lang yung mag-simplify dyan, k in terms of a variable. Okay? So from that, let's now differentiate again. Let's differentiate this. Okay, so that would be 0 is equal to differential of y is y prime. And this will follow again u over v, right? U over v, derivative of u over v. So that would be y double prime quantity squared. So v du. V, ang u is ito. So chain rule, 2 times y prime, derivative of y prime is y double prime. Minus y prime squared, that is u dv. Derivative of y double prime is y triple prime. So simplifying, it will become that one. Okay? Ito na yung pag-simplify natin. Simplifying further, ito. Okay? And ito, ma-add man siya. Kani. And now it would be 3 y double prime squared minus y prime times y triple prime is equal to 0. Well then, no, that is now the differential equation of all parabola with axis parallel to the x-axis. Okay, so medyo mahaba but kaya. No? I know kayang-kaya nyo yan. So again, there are 3 arbitrary constants. That's why we differentiated 3 times. Okay? Kana siya. So from that, this would be our last example. And for you to have a practice problem, no, for this topic, try to solve this one. Try to solve that one. 1 to 6. So I guess that's it. Thank you for watching my video. I hope you liked it. I'll be releasing more of this video soon. No? Next part and the other part. Thank you and have a great day. God bless everyone.